Students, welcome to the last video lesson from integration. In this lesson, I'll be covering the third and the fourth application of integration. So the third application is to find the maximum profit if marginal revenue and marginal cost function are given. Okay, so when MR and MC is given, you will be asked to find the profit function. So P of X is equal to MR minus MC. You integrate these values, okay, plus K. So now let's look at the example here. The marginal cost C dash of X and the marginal revenue R dash of X are given by these two functions are given. So our C dash and R dash is given. So C dash means MC and R dash means MR. Okay, the fixed cost is null term 200. Now here the fixed cost is also given. Determine the maximum profit and the number of items produced for this profit. Okay, so you are given C dash. So C dash means MC is given here. So you can write MC is equal to this value and MR is given for you. So now to find profit, therefore your P is equal to integration of MR. Okay, MR minus MC dx plus K. Now you substitute this integration of, so MR is how much? 30 minus, put inside the bracket, 20 plus X divided by 20 dx, okay, plus K. Okay, so now you may put this one inside the big bracket. So integration of 30 minus 20 minus X divided by 20 dx plus K. So now P is equal to, so now you can integrate. So integration of, you can individually integrate or you can simplify this. So it's going to become 30 minus 20 is 10. So you can write 10 minus X divided by 20 dx. Okay, so we can write this as, which is equal to, so integration of 10 dx minus integration of X by 20 dx plus K. Plus K has to continue, so which is equal to, is going to become 10x minus X squared divided by 2 times 20 plus K, which is equal to 10x minus X squared divided by 40 plus K. So this is your profit function. So now you need to find the value of K and substitute in the profit function. So when X is equal to 0, it's given in the question, when X is equal to 0, your profit or your fixed cost was given 200. Therefore, so 200 is equal to 0 minus 0 plus K, which implies that your K is equal to 200. Therefore, your profit function P is equal to 10x minus X square divided by 40 plus 200. Okay, so now you are asked to find the maximum profit. So you need to follow the steps for maximum and minimum value. So you need to differentiate this. For P to be maximum, your dP by dx has to be equal to 0. Okay, so for P to be maximum, your dP by dx has to be equated to 0. So which means you need to differentiate this. So you find dP by dx, which is equal to 10 minus 2x divided by 40. Okay, this is your dP by dx. Now you equate to 0. Therefore dP by dx is equal to 0, which implies that 10 minus 2x divided by 40 is equal to 0. From here you need to find the value of x. So now this is going to become equal to minus x by 20 is equal to minus 10, which implies that x is equal to 200 if you multiply. So now you got value of x. Now you find second derivative and see whether it is greater than 0 or less than 0. Okay, therefore you have dP by dx, you got it as 10 minus to x divided by 40. Okay, so your d square p by dx square is going to become minus 2 by 40, which is equal to 1 by minus 1 by 20, which is less than 0. Okay, therefore it has what? Maximum profit. Okay, there, since you can write, since d square p by dx square is less than 0, hence it has maximum profit at x is equal to how much? 200. So whatever value of x you got there. Therefore, to find the maximum profit, what you need to do is you substitute the value of x equal to 200 in the original function. So you have p is equal to, so therefore the maximum profit is maximum profit is p of x is given by 10x minus x square by 40 plus 200. So you substitute the value of x here, so it's going to become p of 200, so 10 into 200 minus 200 the whole square divided 200, so which is equal to, you will get 800, the maximum profit. Okay, now let's look at the second example. So in the second example also you are given the marginal cost is given, but your marginal revenue is not given, MR is not given. So the selling price is fixed at nil term 9 per unit and fixed cost is given 1800 per day. Okay, so you need to first find the MR. Okay, so you are not given MC. So question says determine cost function, revenue function, profit function and maximum profit that can be obtained in a day. So you are given MC is equal to 16x minus 1591. Okay, and your selling price is given. So if MC is given, you can easily find your cost price, okay, or total cost. So your total cost is going to be integration of MC dx plus k. So you integrate this. So when you integrate, you will get 16x square divided by 2 minus 1591x plus k. Now when x is equal to 0, c is equal to 1800, right? So fixed cost is given. So when fixed cost is given, you are not producing anything, right? So x equal to 0. Now you substitute this value and get the value of k. Now when you substitute x equal to 0, c equal to 1800, so the value of k you are obtaining is 1800. Hence the cost function is c is equal to, so 8x square minus 1591x plus 1800. Okay, so next you are asked to find the revenue. You know this, when the selling price is given, you can easily find the revenue function. So revenue is equal to selling price into units sold. So r of x is equal to 9 into x. So r of x is equal to 9x. So when you have the cost function and revenue function, you can easily find profit function. So profit function p is equal to r minus c. Okay, so you subtract this, so you're going to get 1600x minus 8x square minus 1800. Now since you are asked to find the maximum profit, so you should know dp by dx must be equated as 0. Okay, and you should check with the second derivative. So now you try to find dp by dx, so you will get 1600 minus 16x. So for maximum profit, dp by dx equal to 0, equate to 0. Okay, and you obtain the value of x. So x is equal to 100. So now you find d square p by dx square. You are getting minus 16, which is less than 0. Since d square p by dx square is less than 0, hence the profit is maximum at x equal to 100. Therefore the maximum profit is, you substitute x equal to 100 in the original profit function. So when you substitute here, you are going to get my nil term 78,200 as the maximum profit.